When astronauts brought back rocks from the moon, scientists were amazed at how similar they were to Earth rocks. This made them curious about the moon's origins. Having a moon at all is unusual. Most moons in the solar system orbit planets far from the asteroid belt, like Jupiter and Saturn. Also, Earth's moon is unusually large compared to Earth, almost the size of Mercury. So, where did this moon come from? The lunar rocks provided a clue. The moon's rocks were similar to Earth's in many ways, especially in their stable oxygen isotopes, O16, O17, and O18. Isotopes are versions of elements with different numbers of neutrons. Stable isotopes don't change over time and help scientists figure out where rocks came from in space. These similarities between Earth and Moon rocks suggested the Moon might have formed from Earth itself. But there were also differences. For example, Moon rocks have fewer volatile elements, things that vaporize in heat, and less iron than Earth. The Moon's tiny iron core is only about 1–2% of its mass, much smaller than Earth's core, which makes up about 30% of Earth's mass. Scientists began to form a theory based on these findings. They suggested that the Moon formed from a giant impact. About 4.5 billion years ago, a planet-sized object the size of Mars, called Theia, collided with Earth. This crash released a huge amount of energy, melting both planets and throwing debris into space. The debris formed a disk around Earth, and some of this material came together to form the Moon. The impact would also explain the Moon's high temperature and its composition. However, there was a problem. Models of the collision suggested that the Moon should have been made mostly of material from Theia, but the Moon's isotopes were too similar to Earth's. This is called the isotopic crisis. Scientists tried different ideas, such as Earth spinning faster or Theia moving at a higher speed. They also tested scenarios where Earth and Theia mixed more thoroughly after the impact. A new model published in 2022 used very detailed simulations to show how the Moon might have formed. This model suggested that the Moon could have formed from 60% Earth material and 40% Theia material. This could solve the isotopic problem. But where did Theia go? A 2023 study suggested that pieces of Theia might still be inside Earth. Earth's deep mantle has two areas called large low-velocity provinces, LLVPs, where seismic waves move slower. These areas might be made of dense, iron-rich material from Theia's mantle, which sank into Earth's core after the impact. So, Earth may have eaten Theia, leaving only traces behind. Scientists think that the leftover parts of Theia may be stored in the LLVPs, but more research is needed to confirm.